Before moving to the other geometric tools in 3D, let us see one very important command, that is UCS. Because with the help of UCS, you will be allowed to change the origin. That is, this is the UCS. You can change its position or you can change its orientation. You can rotate it about X, Y, and Z axis. I hope you are getting my point. Okay, so now let's start. Let me draw a box here. This is the box. This is the cylinder. Okay, now go to UCS command. UCS. See, once you have activated the UCS command, see how the UCS is moving. Okay, because the ortho is on, F8 is on. That's why it was moving straight, either in the vertical, either in the Z direction or in the Y direction or in the X direction, like this. See, suppose you want to move it here, so it will move up to here. Just left click. Or suppose you want to move the UCS in the Z direction by 200. So give 200, enter. See how it has moved. Now it will ask which direction you want. See, specify point on x-axis, means which direction you want as your x-axis. Suppose I want this as my x-axis. So move your mouse in this direction and left click. And now y direction, because see, specify point on the xy plane, because x axis is fixed. Now you have to specify the y axis. So this is your, suppose I want this to be my y axis. So again, left click. So you will see that your UCS is here now and your grid will move here, because this will be the origin now. Okay, you can rotate it. Okay, you can rotate it and see it. Exactly. Yes. Press here so that southeast isometric will be activated again. Okay, I hope you got my point. If you do undo, Control Z, see, it is the previous UCS. Go to UCS again. Okay, so this is how you can set the origin. Suppose I want to specify origin, press F8 so that ortho is off. Suppose I want to shift my UCS here at this corner. So left click there. Now it's time for x-axis. Suppose I want this to be my x-axis. Okay, so put the ortho on. Okay, so I want this to be my x-axis. Okay, so this is my x-axis, this direction, downward vertical. Okay, downward direction is my x-axis. So left click. Okay, x-axis is fixed. Now y-axis. Suppose I want this direction to be my y-axis. Okay, so move your mouse here and left click. You will see that your UCS has changed like this. And the UCS is on this particular box. So Control Z, you will move on to the previous UCS. Now you can see here, one problem has happened. Can you see that UCS? I'm not able to see. Don't worry. Sometime it might happen while doing undo. So go to view and press the UCS icon again. Okay. You will see that UCS icon again. Come to home again. Okay. Now go to UCS. Enter. Okay. Now press F8. Let me set this corner point as my UCS. Okay, this is x-axis. So press F8 so that it becomes straight. See, you have to do zoom in and zoom out simultaneously so that you can set your UCS very perfectly. See, this is my x-axis and this will be my y-axis. Okay, this is the UCS. Suppose you want to name this particular UCS. So go to UCS command. Can you see the named? Go to named. Okay. Yes. Save. Okay. Save. Let me save this name by Deep UCS. Enter. So you will see that here Deep UCS is displayed here. Is showing here Deep UCS. Okay. Exactly. So that's the UCS command. I hope you got my point. Suppose you want to go to previous UCS, go to UCS command. You don't want this UCS, you have option previous. Go to UCS again, previous. Okay, so that's the previous UCS, which it was earlier. Okay, go to UCS command. Now we have UCS. Inside the UCS, face. Go to face. Now obviously you have to mention the face of any solid surface or anything. So let me suppose I want my UCS to be on this particular face, on this face of cylinder. So left click there. Okay, left click there. Now accept it by entering. So this is the UCS. Go to UCS, enter previous. Okay, now again UCS, enter. Go to face. I want my UCS onto this face. See how this X and Y direction has been changed onto that face. Means that face will be parallel to your XY plane. So left click there. Okay, left click there and press enter. So you will see that your X and Y will be there in that face. Yes, that was the face. This is the face which I was selecting. See, so come to UCS, enter previous. Okay, and I want the southeast isometric. Yes, go to UCS again, go to face. Suppose I want here, so select this face. The UCS will shift there. Okay, but you have to enter again. See, the UCS is shifted onto this particular face, right? Yes, UCS, press previous. Exactly. Now go to UCS again. We have one more command called view. If you press view, see what is happening. From your view, you will be able to see X and Y axis. So that will become your UCS. Okay, which is of no use. Go to UCS, previous. Suppose you are viewing this part. You are viewing this part. So go to UCS, enter, go to view. So that view will become your X and Y plane. Means the site, or you can say the site which you are seeing, okay, that will be the perpendicular to the XY plane. Okay, means your site will be perpendicular to the XY plane. Means your view. That's the UCS view. UCS, go to previous, and from here again, not from here, southeast isometric. I hope you got my point. Go to UCS again. Okay, go to UCS again. We have next is world. World UCS will be similar to that only. Okay, that's the world UCS. If you press this, that's the home. Okay, southeast. Okay, world UCS is by default southeast. Okay, go to UCS again. Okay, if you press world, It will be like this. Go to UCS again, press world. Yes. Go to UCS. Now press this X, Y, and Z. Now look very carefully. This X means what inside the UCS? This X is nothing but the UCS will be rotated about X axis. Go to here. I will explain about this world UCS again. Okay, that is nothing other than that. It is as simple. Okay, so go to X axis. Okay, X. Now it is asking rotation angle about X axis. How much rotation you want about X axis? Suppose I want 180-degree rotation. So you can see here about X axis, the UCS has rotated 180-degree. Control Z. Yes. You can see some changes you can observe on our window. Yes. Don't worry. That's the perspective view actually. We'll explain what's that. Yes. No, go to UCS again. Go to UCS again. Go to Y axis. Okay. Y. Put the ortho off. Put the ortho off so that it is not perpendicular. Now you can see the UCS is rotating about Y axis. About Y axis. Okay. Now give 90-degree. So it will be anti-clockwise 90-degree. See, it is rotated by 90-degree in the anti-clockwise direction. Okay. I hope you got my point. Now, whatever you are going to draw here, it will be drawn on the XY plane. Put the ortho off. See here. Yes, like this. What is the advantage of this? Because if you draw a cylinder, this will be the base point now. Okay, base radius and height will be along the z-axis. So the cylinder orientation will be like this. So suppose you want to change the orientation of the cylinder, this is how you have to change. First change the UCS and then you can draw the cylinder. Okay, see, in this type the cylinder axis is along the x-axis, and in this type of cylinder the cylinder axis is along the z-axis. Okay, yes, go to UCS again, enter. Okay, now go to z-axis. Now see here, you can easily see that about z-axis the UCS is rotating. Okay, you can mention any angle, suppose 90-degree, even you can give minus 90 so that it will rotate in the clockwise direction. Okay, plus 90 means anti-clockwise, because in the units by default I always select anti-clockwise. So see, it is rotated like this. Okay, yes. So go to UCS again, enter, press Z axis. Now set the new origin. Suppose this is my new origin. This endpoint, zoom it. This endpoint right here. Suppose this one, this point right here is my origin. Okay. Now specify point on positive portion of z-axis. So put the ortho on, it will be better. So suppose this is my z-axis. Okay. If this is my z-axis, the UCS will form like this. So this is how it works. Go to UCS again. UCS, enter. Okay. Z-axis. We have one more option called object. So go to object, select the object. See, selected object z-axis option not supported for selected object. Yes, let me select this object. It is also not supported. Now, what is the reason behind that? See, this is done now. because this is a solid, this is also a solid, this is also a solid. Okay, so go to UCS again. Okay, suppose if I go to Z axis again, now I want select the object. Now I want this to be my Z axis, because you have to select line only as a object. So select this. You will see that along that line the Z axis will come. Yes, go to UCS, previous, go to UCS again, previous. Okay, or you can do one thing, go to UCS, previous, because I want that initial UCS. Go to UCS, previous, go to UCS again, previous. See, this was the initial. So this is how you can come to the previous one. Okay, so that's the command UCS. This will be really helpful. Suppose you are drawing a wedge. Okay, you are modeling a wedge. We have an option called wedge. Okay, wedge. First you have to mention, let me delete these things. Yes. Okay, wedge. For wedge, WE is the shortcut key. WE is the shortcut key, or you can access from this ribbon bar as well. Okay, now you have to make a rectangle first. So specify first corner, this is the other corner. Okay, now height of the wedge. You can see the slant height. Let me explain the wedge like this. What do you understand by wedge? This is the side view of the wedge. Okay, this is the side view of the wedge. If you see this view, you will be able to see like this. If you see this view, you will be able to see like this. A rectangle. A rectangle, right? Yes. A rectangle you will be able to see. This is the slant height, you can say. Slant one. Okay, slant, inclined one. So, suppose if I put a ball here, if I place a ball here, so that ball will roll along this direction. Okay, along this direction. Now, you can see one thing. If I put a ball here, that ball will roll along this direction. Okay, that ball will roll along this direction. Exactly. That is along x direction, you can see. Let me draw wedge again. See, if you place a ball here, the ball will roll along this direction, and that direction is nothing but your x-axis. I hope you are getting my point. Now, let me erase these things. Select it and delete. Now, let me change the UCS. Go to UCS. You can access the UCS from here as well. See, you can see that. Go to UCS, enter. Okay. See, suppose I want to rotate my UCS about y-axis. Okay. Put the ortho of. Suppose I want to rotate by 90 degree. So see how it is rotated. Yes. About y-axis, it is rotated by 90 degree. Now, go to wedge. Okay. First delete this cylinder. Go to wedge. See, the rectangle will be drawn on the xy plane. This is the major rule. Then the inclined, see the inclined portion. You can see very well, if you place your ball here, it will roll down in this direction. Okay, if you place your ball here, it will roll down along X direction. See here, means one thing is for sure, that the wedge inclined the inclined one side will be always along your X direction. That's the rule. Go to SE isometric again. I hope you got my point. Now you can do previous UCS. Go to UCS, previous. You will get the original UCS. So I hope you are getting my point. Okay? Yes. Suppose you want a wedge like this. Okay? In this direction. So put your x-axis, means you want to do your x-axis in this direction, in this particular direction. So you can rotate your UCS about z-axis, in this direction. So put the ortho on and do like this. See, now the x direction is along this direction. What I did, again the UCS icon has gone. Go to view, because I did undo UCS icon. Okay, now go to UCS. Okay, go to UCS, z-axis. I want to rotate about z-axis, and I want my x-axis to be in this direction, so that your wedge inclined face is along that direction only. Okay, so put the ortho on and left click. Go to wedge, draw a rectangle, and like this. You can see the wedge is drawn. It's very simple. Okay, now we have some more commands inside wedge. So go to UCS and then previous. Go to UCS, previous. Okay, delete this wedge. Go to wedge. Okay, now we have center. So center rectangle will be drawn first and then height. Now you can see the height which I am specifying is half above the grid and half below the grid. Okay, exactly. So that's the wedge. Go to center again. This is the center rectangle. Yes, you can see here. Or you can use 2 point. You already know what is that 2 point. Okay, first point, second point, like this. It's very simple. Go to wedge again, first corner. Now let's go to cube. Okay, cube means what? See, if you cut your cube, let me explain this with the help of one note. See, this is your cube, right? Now, if you cut your cube from here, you will see a wedge. Okay, if you cut your cube from here, you will see a wedge. See, let me specify length. Let's say the length is 100. Enter. Okay, means this side, the length of this side will be 100. The height of the wedge is 100. Okay, and this width of the wedge is again 100. I hope this is clear. Okay, now you can mention length. See, this is the length. This is the length of the wedge. The length is along x-axis. Suppose I want it to be 200. Now width. See, this is the width. Width will always be along y-axis. Let us say width be 20. Okay. Now height. Height. I want 150. So height will always be along, the height will always be along z-axis, the length will always be along x-axis, and the width will always be along y-axis. Okay, let me show it here. See, this is the wedge which I am drawing again and again. Okay, yes. So this is your width. This width means the wedge you have drawn means the UCS must be like this. The UCS must be like this. This should be your x-axis. This should be your y-axis. And this must have been your z-axis. Okay, this is your width. This is your length. This is your length. This is your width. And this is your height. Yes, exactly. This is your height. Height of the wedge. Height is along z-axis. The length is along x-axis. And the width is along y-axis. I hope you got the concept of wedge. So whatever be the UCS, whatever be the UCS, the wedge will be modeled according to the UCS only. It will automatically be done. Yes. As you change your UCS direction or orientation, then the wedge direction will also be changed. Okay. Yes, already we have seen that. Now let's move on to the next geometric tool, that is torus. Okay. So specify center point. Let's say this is the center point. Specify radius. Let me give 100 as my radius. Okay. Now we have to mention the tube radius. Tube radius, let us say 10. So torus is used to make what can I say, tube like shape. Okay, tube like shape. As I have mentioned here, two radius. One is the center line of this tube, that radius, that center line radius, and another one is that tube radius, the tube. Okay, you must have seen your tire tubes in your bikes, in your cycle. That's the torus. Okay, means you can say it's a 3D donut. Okay, see, it is same as that circle only. See, we have 3 point. Go to 3 point. Let's say this is the first point. This is the second point. This is the third point. Now you can see here. 1 second. Okay, that line is not on the grid. See, that's why it was happening like this. Okay, so let me delete that because it is out of the grid. Go to torus again. Select this, select that, and okay, put the ortho off. That's why it is not getting picked up. Put the ortho off. Now it will be picked. Yes. Now tube radius. Let's say 20. See, this is the tube radius. Okay. Go to torus. Okay. For the torus, TOR is the shortcut key. For the torus, TOR is the shortcut key. 3 point, first point, second point, and the third point. Tube radius as 20. Enter. So this is the 3 point torus. You can also mention 2 point. Okay, TTR. Okay, means first the initial circle which I am drawing, that will be the center line of the tube. Okay, so let's go to TTR. This is the tangent. This is the tangent. Let's say radius be 150. Torus does not exist. Okay, not an issue. Yeah, they are on the same plane. Okay, not an issue. Now go to torus again. Go to TTR. Might be that radius is very big. Okay. Now let me give it as 100. Torus does not exist. Means we have to specify some more smaller radius. This is a tangent. This is the tangent. Let's say the radius be 50. Now, why it is happening? Torus does not exist because if you see from the top view, press here, you can see the top view because these two lines are on the xy plane first and they are parallel to each other. Okay, that's why torus is not getting done. So go to southeast isometric again, like this. Okay, okay. Go to torus, go to TTR, select this as tangent and this as tangent. Now it will be done. Select the radius, let the radius be 100. See, tube radius, let the tube radius be 15. Enter. So this is how the torus is modeled. I hope you got my point. Yes, so that's all about torus.